Good afternoon, everybody. Welcome and thank you for finding the time to attend our October lunchtime lecture today. My name is Charlie Nicklin. I'm the CEO of IAgrE and I'll be your host today. I'd like to welcome Professor Jane Rickson as our speaker today. I'm sure many of you know Jane as a past president of our institution, but for those that don't, Jane is Professor of Soil Erosion and Conservation at Cranfield Soil and Agri-Food Institute. Professor Rickson has over 30 years experience of research, consultancy, teaching in soil and water engineering, specialising in soil degradation processes and sustainable land management. Her work has focused on better understanding of soil functions and their role in the delivery of ecosystem goods and services, including water regulation, agricultural production and carbon storage. In today's lecture, Jane will be talking about her work with farmers and advisors in improving soil health by using practical and cost-effective soil conservation measures. Just before Jane starts, I was going to mention some house rules, but Sarah's already done that. So you're all muted, and then use the chat function at the bottom of your screen, and then the end of presentation will unmute you so you can ask your question. So enough from me, over to you, Jane.
Thank you, Charlie, and good afternoon, everybody. I will try and share my screen now, so bear with me a second while we get the technology sorted. Bear with me 1 second. Okay. Right, is that coming out as presentation mode?
Not as yet, Jane. It's just that's right now.
Is that all right now?
Yeah.
Okay, very good. Right. So good afternoon, everybody. I'm afraid I'm going to have to refer to this screen as I give my presentation. So I've been invited, thank you very much for inviting me to give this lunchtime seminar, which is about soil conservation in the UK. I often talk about soil erosion, soil degradation processes, which I'll talk a little bit about to justify the need for soil conservation. But I'm going to try and concentrate on some of the research, applied research that we carry out at Cranfield and previously at Silsoe College on soil conservation in the UK. Okay, let's, without further ado. So what I want to try and cover in the next half an hour, 40 minutes, something like that is, first of all, why do we need soil conservation in the UK? Is it really such a problem, soil degradation? Is it such a problem that we need soil conservation? Then I want to talk about some of the soil conservation practices that we use to both reverse and prevent soil degradation, and some of the research that we've done to try and quantify the effectiveness of those different practices. Then I want to talk a little bit about the future of soil conservation. Where are we going with soil conservation, particularly in the light of climate change? Does that require more soil conservation, or have we got our act together? And then I'd be delighted to take any questions and answers that anybody may have. And I'll pass them on to Gordon, who will know more than I do. Okay, all right. So why do we need soil conservation? Why is there a necessity to have soil conservation in the UK? Surely we don't have soil degradation problems, or do we? I love this quote. I think this quote will be on my gravestone, that it really, for me, captures what we're trying to achieve here. And this is the quote: that the thin layer of soil covering the Earth's surface represents the difference between survival and extinction for most terrestrial life. And I think if you think about how thin the soil resource globally is, I mean, 75% of the globe is actually water, so it's not actually land. And of that quarter of the globe surface that we have, soil is just like the equivalent of the apple peel on that very limited, finite land resource. And of course, the soil, and the topsoil in particular, is really, really important. And I've shown in some illustrations here on the left-hand side, you'll see some very, very thin chalk soils up on down in the South Downs in East Sussex. Really, really thin soils, which are eroding at very high rates. And we've just carried out a study for DEFRA actually to identify that there are some areas that at current soil erosion rates, there will be no soil left, no topsoil left. And this is really, really concerning where we have these very shallow, vulnerable soils. And we see erosion problems. The middle picture there shows some erosion on some of the Hereford soils, very sandy soils, very prone to erosion. And then the image of the country, the nation, you can see where that soil is all ending up out into the oceans and seas. And that's our soil, that's our precious soil, which takes thousands of years to replace once it's gone. And really, this demonstrates the need for soil conservation. And again, the final photograph that I've put there is of the US Dust Bowl, which we know was a devastating effect on the economy, on the environment, and on farmer livelihoods in the 1930s in the US. And out of that came the United States Department of Agricultural Soil Conservation Service. And it was because of that devastation of the soil resources that led to the founding of soil conservation and the need for soil conservation in the US. Again, this slide really shows again the need for soil conservation. I've mentioned there's an increasing pressure on these finite soil and land resources. We need to get our fuel from somewhere, our food from somewhere. We need to build infrastructure to cope with the predicted 9 billion people on the planet by 2050. And yet we only have these finite land resources, soil resources, which are being increasingly intensively used, which is leading to soil degradation. And it's estimated that there's 12 million hectares of agricultural land worldwide that are lost to soil degradation every year. Again, it's not just me saying it because it keeps me in a job to demonstrate the problem of soil degradation. It's been identified by people like DEFRA. If you look at their Safeguarding Our Soils document and their current 25-year environment plan, they talk about the loss of healthy soils and soil degradation. In the EU's thematic strategy for soil protection, favourite publication of mine, I have to say, it talks about the degree of soil degradation throughout Europe and the need to then control that degradation. So what do we mean by soil degradation? What are these processes that then justify the need for soil conservation? And this diagram in the bottom left shows these degradation processes of soil erosion, complete loss of soil through rainfall and wind and mass movements and so on. Compaction, something close to Gordon's heart, of course. Floods and landslides, salinization, sealing, meaning surface sealing from urban development, infrastructure projects, and so on. Contamination, decline in biodiversity, particularly soil biodiversity, earthworms, microorganisms, and so on. And then very important at the moment when we're trying to decarbonize agriculture, the role of organic matter and soil carbon and how that is being lost to the atmosphere through our intensive land use practices. So I'm trying to I'm painting a very negative downer Debs type picture here in terms of the problem, but then hopefully as the talk develops, I'm going to talk about what we can do about it and actually reverse and prevent some of these processes. In my talk, I'm also going to just focus on soil erosion. I hope that's okay. Obviously, we do work in all these other degradation processes, but just because of the time available, I'm just going to really focus on soil erosion, which not least because it's the closest to my heart. So, okay, carrying on with well, how bad is the problem that we really need a soil conservation programme in the UK? I've selected some pictures from my picture gallery of the work that we're doing in the field with farmers that are suffering soil erosion problems. Many of these pictures you will see illustrate or feature my colleague Rob Simmons, who is also very active in this area. And all of these pictures are taken from Herefordshire, very, very sandy soil, very erodible soils with highly intensive land use. And you can see the degree of soil loss and soil erosion that is occurring. And we see this really on an annual basis. that these soils are washing away into the Bristol Channel and causing all sorts of problems on site in terms of farm management practices. Gullies, by definition, I love the definition of a gully, is that you cannot cross it with farm machinery. So rather than trying to quantify it and say it's 3 meters deep or it's 6 meters deep or whatever, the definition is that you cannot cross it with farm machinery, and that influences farm activities and really the economy of operations on that field. And it's not only where the erosion takes place, it's the off-site impact of all that soil washing off into roads, blocking culverts, causing all sorts of aquatic ecology problems off-site. And our work is actually trying to quantify how bad the problem is, again, to justify soil conservation measures. The map on the left-hand side is some work that I was involved with, led by Exeter University, looking at the degree of surveys of soil erosion studies throughout England, throughout the UK, or throughout England, Scotland and Wales, I should say. And you can see Pierre Birnot collated all of the quantified data on soil erosion rates in those nation states. And some of that work has reflected some of the field work that we've carried out, where we've been monitoring runoff and soil loss from different land uses at different times of year. The fieldwork obviously is the most appropriate scale, but we also carry out lab experiments and we carry out some modelling work as well to try and estimate just how bad the problem is. And to try and put some numbers on this, our studies have looked at the problem of soil degradation to justify soil conservation. We looked at different types of erosion or soil loss, first of all by wind erosion, then by tillage erosion, which includes where ploughing direction, particularly up and down slope, actually moves significant amounts of soil, which is a form of soil erosion. And obviously the deeper you're ploughing, the more movement of soil that may occur on that particular field. Co-extraction with root and crops and farm machinery. The middle photograph there shows a harvest of onions, but if you look closely, a lot of those, the harvest is actually just large clods of soil that have been removed during the harvesting process. Now, not only is that losing soil from the field, but it's also causing the farmer a great problem in terms of having to grade that soil away from the crop, the valuable crop that he wants to go and sell. So this co-extraction of soil with crops and indeed on farm machinery, tracks and tyres and so on, is a big problem and can cause fairly high degrees of soil erosion in particular locations, particularly on wet soils. And then again, most of my talk today is going to be talking about erosion by water, by rainfall and by runoff. And you'll see from the table there that the highest rates of soil erosion have been monitored or measured on by water on fields affected by runoff and rainfall. And these figures, well, they're fairly meaningless. What exactly, we measure soil erosion in tons per hectare per year. Well, what does that actually mean? Is that bad? Is it good? How do we actually quantify that, or how big is the problem? And I think if you compare these rates of erosion with, for example, the rate of soil formation. So these soil erosion rates are basically how much we're losing. Well, how much are we then gaining to compensate for that through soil formation rates? And a very large review by a colleague, ex-colleague, Frank Verheyen, found that the soil formation rates in temperate parts of the Europe is around about 1 tonne per hectare per year. That's how much we're getting in terms of soil formation, weathering of saprolite and subsoils and so on. And you can see there's a mismatch between the rates of erosion that we can observe, as much as say 15 tonnes per hectare, and then the rates of soil formation. And that means that we are losing this precious resource and it's not being replaced. Hence the need for soil conservation. And I've mentioned, again, another way of looking at this is, well, the so what question. Well, so what soil erosion, how important is it? Well, we found that we can certainly get an irreversible loss of this natural resource. I've mentioned soil formation rates are very, very low. And so we are effectively losing that soil resource forever. And it's associated with things like yield decline. This graph at the bottom was a very, very simple experiment that we carried out for DEFRA, where we looked at different rates of soil depth representing different eroded phases. So this is a nice, relatively deep soil that will have undergone erosion, which then reduces the soil depth to only 30 centimetres. And again, further erosion reduces it to 10 centimetres. And you can see the yield declines, not surprisingly, associated with that loss of soil depth through erosion, are quite significant. In fact, they were statistically significant. And that implies that we are able to produce less food and fodder and biofuel where we have these shallow soils subjected to erosion. So there is a real impact on things like food security in terms of these degradation processes. Not least the costs that are incurred by farmers to actually have to replace things like the nutrients that have been lost in the soil. And often those impacts on food production from reducing your soil depth are often masked by things like, well, we're losing water holding capacity, but we can irrigate. We can add water in another way by adding irrigation, or maybe adding more fertilizers to compensate for the fertilizers that have been lost in the eroded soil. But those are obviously got costs associated with them, and the question is whether they are sustainable in the long term. Off-site impacts of soil erosion, again, I mentioned these are problematic in terms of soil erosion and runoff from agricultural land is thought to deliver up to 70% of sediments, and that's your fertile eroded topsoil that is being lost. 60% of nitrates, 25% of phosphates. So it's not just where the erosion occurs, it's where that sediment all ends up. Again, the costs associated with that to justify soil conservation. We did a study for DEFRA because they asked the question, well, how bad is the problem? Do we need better soil protection policy in the UK? How bad is the problem? And we collated, and forgive me, a lot of you will be familiar with this, but we worked with economists and field scientists and erosion scientists, soil scientists, to actually come up with a cost of soil degradation. This is just for England and Wales. This is some work that my colleague Anne Graves and a team of us worked on to try and put an economic cost to these soil degradation processes. So what we did is we looked at these different processes, soil erosion, compaction, loss of organic matter, and so on. And we estimated how much loss of these goods and services do we suffer under those different degradation processes. So we divided it into things like agricultural production, how much yield decline is associated with those degradation processes, how much flooding occurs and the cost of that flooding, what's the impact of water quality and water treatment if you've got all of this sediment in your water courses. What about greenhouse gas emissions? We hear a lot about carbon budgets and carbon trading. How much greenhouse emissions come from degradation processes? And other things like cultural impact. Well, I mentioned the impact of erosion on field operations. If, for example, you have an eroded footpath in the Peak District, does that spoil people's enjoyment of that environment because it's a degraded environment with eroded channels? They can't walk on the footpaths because they're degraded. They have to take alternative routes. These are the sort of cultural impacts of soil degradation processes. You'll see there's a lot of question marks where we just don't have the data. We don't know to what extent loss of organic matter, for example, affects flooding costs. So there are lots of question marks, a lot of question marks about the impact of loss of soil biology on those goods and services. But the bottom line is that we came out with soil degradation is costing England and Wales alone about £1.5 billion per annum. That is the cost associated with soil degradation just in England and Wales. We did the same exercise for Scotland as well and came up with figures there. So you could just take that headline message that £1.5 billion per annum is costing the UK economy. So surely that justifies the need for soil conservation measures to rectify that degradation process. All right, so that's miserable. That's really down a debs in terms of the problem. What can we do about it? How is applied research being used to overcome some of these degradation processes? What we're after, what we hope for in soil conservation, our aim is to basically to maintain a fertile seedbed and root zone whilst retaining maximum resistance to soil degradation. So it's not just about stopping these processes. We have to bear in mind that actually many of these processes are actual natural process. Erosion is a natural process, but usually it's in balance with the rates of soil formation. But we also have to bear in mind that we do use soils for things like crop production. We do need to cultivate soils. We do need to manage soils intensively to enhance productivity, for example, the quantity, quality, and reliability of marketable yield. But at the same time, we need to control these soil degradation processes that are impacting our ability to get things from soil. And I would argue that if you've got both the enhanced productivity, you're getting stuff from soils, but you're also controlling soil degradation, that underpins the concept of sustainable intensification that we hear about so much. So in other words, we'll be producing more quantity, quality, and reliability of marketable yields. And that includes things like wildflower meadows. I'm not just saying it's about agriculture, it's about other environmental services too. But you're getting that production, you're getting more from the land, but with less environmental impact. And I would very simply say that if you've got that production and you've got the control of degradation, 1 + 2 = 3, you've got this concept of sustainable intensification. So what are these practices that we can implement, that we can work with farmers, that we can implement in the field that will enable them to get economic returns from their farm, from their land, but without incurring these environmental degradation and social costs? And I'm afraid I'm going to go through a bit of a shopping list now. Apologies for that. But just to give a flavour of some of the research projects that we're working on to look at some of these soil conservation measures. To be complete, there are a number of different methods that are used by farmers and land managers to try and conserve and preserve soils. Cultivations and tillage practices, cover cropping, field engineering structures, erosion control products, soil organic amendments. Again, I don't have time to cover all of those in the presentation today, but I'll just give you a flavour of some of the work that we've done in these areas. The first project that I want to introduce this afternoon is a project that we did a few years ago now called the SOUP project, which stood for Soil and Water Protection in Northern Europe. I can be very cynical. It's often one of these things that you need the acronym first and then you work out what the acronym actually, what words actually fit the acronym. But anyway, as you can see, it's a large multi-partnered project that involved academia, non-government organisations, commercial enterprises, and most importantly, farmers. And we were basically trying to develop evidence of conservation, quantified evidence, to build up confidence in the use of conservation agriculture to improve soil conservation practices. It was carried out at various sites. We had 2 sites in the UK, down in Somerset and in Leicestershire at the Allerton Trust, and then we had partners from throughout Europe. What we were trying to demonstrate in this research project was the viability, effectiveness, and benefits of conservation-oriented land management to improve catchment water quality, protect soil resources, obviously soil conservation, and to promote biodiversity. And we were trying to see whether conservation agriculture was as good as the claims were made in terms of reducing pollution of water resources with soil and nutrients and so on, improving biodiversity, protecting soil resources. We set up a number of soil erosion plots at the different sites, and they were at a scale where the farm operations could take place, using different soil management practices. We had a conventional treatment where the farmer was ploughing, inverting the soil, carrying out secondary cultivations. In other words, business as usual. We then had what we called a SOUP treatment, which was a minimum tillage direct drill with a cover crop. So that's really conservation agriculture with belt and braces, direct drilling and cover cropping. And then we had what I think is probably the most exciting thing about this project, was that we had what we call farmer preference. Because you can imagine, we went to the farmer, we said, right, we want you to change your practice, we want you to carry out minimum till, never done it before, and we want you to introduce cover crops, never used before. And the farmer just would reject that. So he came along and he said, well, this is as far as I will go as far as conservation agriculture. Given the bit of kit in my barn, given what I'm comfortable with, this is what I would apply, and what I would call the best management practice I'm comfortable with. So we called that the farmer preference. We set up these erosion plots so we could measure runoff volume, sediments, pesticides, nutrients and carbon that was carried away by the runoff and the erosion. We also looked at biodiversity as well on those plots, but I'm just going to concentrate on the erosion work that we did. So here are our plots. We had our conventional practice, we've got our minimum till practice, and then we've got what we call our farmer's preference. And erosion plots that were representative of field scale, which is such a rare thing, I'm afraid to say, because of cost and the logistics involved. There's lots of research going on in soil erosion and conservation, but whether it's at appropriate scale is another matter. And we basically collected the runoff and the erosion from those plots. We monitored it remotely. And needless to say, our hypothesis would be that we'd get less erosion where we had that minimum tillage and cover cropping. And indeed, that's what the results, the evidence demonstrated, that those practices did reduce the amount of runoff, but also the sediment and the nutrients within that sediment. So we're beginning to build an evidence base that we hope is useful to farmers to give them confidence to make the transition from conventional practice where degradation can occur to more conservation-oriented practices. My second case study, if you like, was a fabulous bit of work that my colleague, Dr. Joanne Niziolomski, carried out down in Herefordshire, with support from John Chin, who's an asparagus farmer down there, fantastic man, great vision, a visionary in terms of soil protection, fascinating man to talk to. And John was suffering from soil erosion problems. He'd be the first one to admit that on his land, asparagus was causing him all sorts of problems, and the EA were not happy with him at all. But he came to us and asked us, right, what can I do about this problem? What are the practical measures I can use? And Joe's PhD was all about using different conservation measures, things like using mulching and composts within the furrows where this runoff and erosion was occurring. She also looked at different tillage equipment or different bits of kit that would actually break up some of these compacted layers that were leading to this runoff and erosion. And she carried out a number of tests using different configurations, using our soil bin at Cranfield, but also out in the field, to look at different bits of geometry, different bits of kit, to see the degree of surface disturbance. And what she was aiming for was to break up these hard pans, these compacted layers that led to runoff and erosion, but without damaging the asparagus roots. And asparagus is very, very tetchy about getting damage to roots and doesn't like having wet roots, and it really suffers. So Joe was looking for really a compromise between breaking up this hard pan, but at the same time not damaging the asparagus roots. And by the way, asparagus is a perennial crop. It's in the ground for 10 years. So it's important that we get the rooting right. And again, her studies looked at things like the combination of where we've got mulching and where we've got these different bits of kit. And she again could generate quantified data looking, in this case, this is total runoff. And you can see, not surprisingly, when you have a straw mulch applied to those furrows, then you are suppressing the runoff and the erosion associated with that. And again, she observed that depending on the different bit of kit that you use to try and break up that compaction, again, that had significant effects on how much runoff and erosion was generated. And John used this information to then actually apply different tillage and mulch techniques on his land to reduce runoff and soil loss. Another piece of work, again, looking at soil conservation. This is in maize trials. This is a colleague, Dr. Alexandra Cook, who's now at Severn Trent Water. And her PhD was looking at filter socks that are used at the bottom of fields to collect any sediment that's been generated on that field. And the idea is that if you then fill the filter socks with wood bark or compost, first of all, it stops the sediment getting into the watercourses. But she also used different phosphate absorbing materials within those filter socks that also stripped out the phosphate from the runoff and the sediment. I'm not a great fan of these, I have to say, and Alex knows this, because I think they are for sediment control, but they're not for erosion control. They still allow the erosion to continue on the field, but they simply stop that erosion getting out into the watercourses. Now, so therefore, there's a bit of a debate as to whether these filter socks, they certainly do stop sediment, they stop phosphate, but they don't stop erosion. Should we be working for more on-site erosion control measures where the erosion actually takes place? Talking of that, this is another soil conservation measure that we used on John Chin's farm. Again, I don't want to knock John Chin, but I have to praise him for then actually doing something about the soil degradation problems there. And John was suffering from these problems, and we came up with a solution that we imported actually again from the US. Now, when I started my job back in 1985, the thought of actually using grass waterways and terraces in the UK was completely alien. But I don't know whether that is just an indication of climate change or intensification of land use, I'm not sure, but we now work with John every year in putting in more grass waterways and oriented rows and buffer strips to try and control the runoff and erosion problem. So what we do, first of all, is that we carry out a field survey and erosion risk assessment to identify potential locations for these grass waterways. And the idea is that the asparagus rows are then oriented to serve these grass waterways, to then feed into these waterways that collect the runoff and erosion that is being generated on that field. We use the principles of open channel hydraulics to then design the wetted perimeter and hydraulic radius and width and depth of these channels. So this would be our eroded case. We work out how much runoff is being generated into that waterway, into that eroded channel, based on the catchment characteristics that are then feeding into that channel. And from that, as I say, using open channel hydraulics, we can then calculate the channel dimensions. We then obviously have to sacrifice some of the crop to place this channel, which we then line with a jute geotextile, which will degrade in time, whilst the grass in that grass waterway is then established. And you can see by the end of the process, we've got this lovely tufted, high cover grass that intercepts all of the runoff that's generated from the asparagus rows, and then collects that runoff, and any sediment that might be generated in that runoff is collected within that grass waterway and never reaches the waterway itself. And if you combine this with then Joe's work on the use of mulches and tillage in the asparagus rows, then John is now seeing only clean water and much coming off his fields, and much less water and soil losses. Talking of geotextiles, just want to very quickly introduce again some work that we've done to try and evaluate, put numbers as to how these measures actually work. Are they effective? And this is some work that isn't just confined to agricultural. I know IAgrE is about land-based industries, and I know we often focus on agriculture, but I think more and more we're looking at soil degradation problems in other land-based sectors, such as the construction industry and civil engineering and infrastructure engineering. And this is where geotextiles are coming to their own. They're not new techniques, they've been around actually since ancient Egypt, but the use in erosion control is a fairly recent development. But there's loads of these products out there, commercially available, but I was shocked as to how little quantification and evaluation of these products there is. Very, very few studies have actually estimated the performance of these different products. And as you can see, there are many different. Some are made out of synthetic products, polypropylene, nylon, so on, and others are made of materials such as jute and coir and wood chip, wood bark, and so on and so forth. And there are different specifications as to whether they're placed on the soil surface to prevent erosion or whether they're buried. So we've had quite a long track record of testing these different geotextile products to see which are the best and which are the worst, and why do they work, how do they work in controlling processes of erosion. This is just some of the data that we've come up with, again, to help not only end users to specify the right product, but also to help manufacturers design effective products. And I've just selected this as one slide of some of the results that we've got. And one of the number of things I want to point out here. Here are all our different geotextile products currently on the market. One thing you can see, they all perform differently. So there is a differentiation of those products, which are often not reported in the commercial literature associated with them. Some of the products actually increase erosion more than if you hadn't got that product there at all, which is extraordinary that you are paying something like probably £10 a square metre, probably, for some of these products, and they actually are increasing your erosion rate. And that's extraordinary when you think about the implications of that. The other thing I would say is that we found out that they perform differently depending on whether you've got high rainfall intensity or low rainfall intensity, again, something that the manufacturers do not report. And we also found that their performance varies depending on the type of soil that you have. So again, this really uncovers lots of information about how these particular products that are used in many, many civil engineering products, you'll see them out and about as you go around, that there isn't the quantified data. And again, I'm cutting to the chase very quickly here, but this research has led us to start to correlate different geotextile properties, in other words, the material properties of those different products, with their performance. You know, how well do they perform? And we found that the most important properties are things like the area of the soil that is covered. That's pretty obvious. Their ability to impart roughness to flow, their ability to hold water, the weight of the material when it's wet, particularly after 24 hours. All of these properties are highly correlated with erosion control effectiveness. In other words, if you want a good product that works well, check these different properties to see whether you've got a good product. What I'm also really interested in is look at the things that often specifiers go on, things like cost. Well, actually, there is a very poor relationship between the cost of these products and how well they work. So buyer beware. Our research has actually given some intelligence, if you like, in terms of choosing products that are going to be most effective. Oops, sorry. Oh, come on. Oh, there you go. Very good. Okay. I just want to finish off now by having gone through my shopping list of some of the research that we've done on soil conservation measures that could be used to address some of the soil degradation problems I've identified. I want to look to the future and ask the question, what is the future for soil conservation in the UK? And I think if you look at some of the climate change predictions, the IPCC, for example, and UKCP 2018, UK climate projections 2018, you will see that many of those climatic trends that I've listed on the left-hand side of this table, increasing summer temperatures, higher winter rainfall, more intense downpours, more winter storms, all of those climatic changes are going to have an effect on soil erosion processes. And the news is not good. Well, it's good for me because it keeps me in a job, but it's not good in terms of erosion is likely to increase, soil erosion is likely to increase as a result of those climatic trends. Particularly the fact that we're likely to have more intense, more frequent, longer duration rainfall events, which are going to lead to wetter soils, more runoff and more soil erosion. And it did make me think that, you know, as I mentioned earlier, some of these soil conservation measures that I would never consider in the mid-80s now are used on an annual basis in that time span. I wonder to what extent other soil conservation practices that are used worldwide might well come into practice. And these are some of my most preferred pictures of soil conservation from around the world, where we have on the left-hand side channel terracing that is used to break up slope lengths to try and reduce the amount of runoff that's generated there. The middle slide shows bench terracing, which is used in Mediterranean Europe, again to compensate for the fact that we've got steep slopes and high rainfall to try and control soil erosion. And then the final slide there is of the Philippines, where, okay, this is a bit of a cheat because it's not really for erosion control, it's actually for paddy rice production, but it is the most beautiful slide of these bench terraces that are used to conserve soil. And I wonder, I question whether, given the trends in climate and the intensification of agriculture and land use, whether or not we will start to see some of these practices in the UK. And my final picture on this slide is actually how things go around and come around. This is a picture, I get very emotional about it because it's got my husband and my two little girls. This is a picture of strip lynchets, which are actually Roman bench terraces. And this is down in Dorset. And you'll see on an Ordnance Survey map, wherever you see the word strip lynchets, these are actual bench terraces that were used by the Romans in this country. So maybe it's not a matter that we start to introduce these bench terraces, but actually we'll go back to how agriculture was practiced back in Roman times, where bench terraces were deemed necessary. My final slide really is just a word of warning and also a bit of an advert, I suppose, for the work that we do in soil conservation. This is a metadata analysis that I did of all different measures of soil conservation that I could find in the literature. And I simply reported the effectiveness of those different erosion control measures from the literature. And you will see that many of them vary quite a bit in terms of how effective they are at controlling erosion. And the range of values is quite high, and some of them are actually not as effective as we might think, which means that we really need more evidence as to the effectiveness of these soil conservation measures and indeed how they work. So I'll just give you some take-home messages in case Dio has fallen asleep, given that he's on Australian time. I will just give you some take-home messages that you can wake up to now, that soil is an essential part of the delivery of several goods and services to society. Soils can be irreversibly degraded and damaged by processes like soil erosion, but soil conservation practices can be used to reverse and prevent soil degradation, as I've hopefully tried to demonstrate today. The last point I'd say is that no matter how effective your solution is, no matter how technically well it works, it will fail without the right economic and social conditions. So it's all about working with farmers and land managers to see whether they are willing to adopt these practices that will fit into their farming practice. So I'd like to thank you for your attention. I'd also like to acknowledge many of my colleagues that whose research I'm reporting on today. Rob Simmons, Joanne Niziolomski, Alex Cook, John Chin, the SOOP team, Roy Morgan, who gave me my first job in this, and I'd like to really acknowledge him, and many others that I've worked with. So thank you very much, and I will stop sharing my screen now. Thank you.
Okay, thank you, Jane. There is a question. Sarah might need to help me.
No problem. I think.
It's come back. My chat screen's come back.
Okay, good. I know Dio sent me a private question by mistake, so perhaps we could start with his question, because you may not be able to see that one, Charlie.
No.
Dio, would you like to unmute and ask your question?
Yeah, sure. So, thank you for that. Sorry, I sent it mistakenly to you. No, I was interested in the filter socks, Jane, and I wonder if that could be a potential solution for soil losses, to manage soil losses from tram lines, and in our systems here in Australia for controlled traffic farming systems, where you have only 10 or 15% of the field cropped area affected by traffic, so it's very localized, and you could potentially use that to break up the slope and the length of the slope by placing those socks.
Mm.
What do you think about that?
Yes, I was a little bit unenthusiastic about filter socks because they are a sticking plaster approach. What I didn't say, and you've alluded to in your question, is that I think if they are put at critical slope lengths down your tramway or indeed down your field, then actually they can be effective at controlling erosion as well as sediment. And what I mean by that is that we can calculate the critical slope length at which runoff becomes erosive. It's actually able to detach and transport soil particles. And when we calculate that critical slope length, if we then put our filter sock or our buffer strip at that point, theoretically, no erosive runoff should be generated on that slope. So that, yes, you'll still get runoff, but it will never reach the velocity at which detachment and transport of material will occur. So for that, in that application, filter socks can be useful for erosion control as well as sediment control, but hopefully you haven't generated any sediment. And certainly with these P absorbing materials, they can actually strip out any phosphorus, any phosphates that you actually have in the runoff and sediment. So yes, I think that would be an application of them. You would need to calculate that critical slope length at which you would then place your buffer strip. But Dio, I can, I'll gladly share Alex's thesis with her permission, obviously. But if that would be of use, then I can put you in touch with Alex.
That'd be great. Yeah,
you might even be on the call. I'm not sure, but I could put you in touch with her.
that'd be great. Thank you so much.
No problem. No problem.
Okay, Fred Clark has a question. If you want to unmute.
Hi, yeah, it's quite an interesting presentation. I noticed during the presentation there was no mention of land drainage, tiling, whatever you want to call it, from which part of the world in. Has any research into that and the effect of soil profile, water levels and runoff been looked at?
Thank you, Fred. Yes, a lot. I know it was an omission not to look at drainage. My aim is really just to look at soil erosion processes. Now, obviously, those need runoff to be generated. If you can reduce that runoff through infiltration and drainage, then you won't have an erosion problem. So, and indeed, drainage is going to be very important in controlling runoff for runoff's sake in terms of water conservation. But I was focusing mainly just on controlling erosion in terms of detachment and transport of soil material. So I didn't include drainage. I could have if I was looking at trying to control runoff in the first place. But yes, there's been lots of research that's looked at that. And again, I can direct you, I'm sure you'll be familiar with that, but I can direct you to the literature on how drainage is used to control runoff and therefore control erosion. Does that answer your question, Fred?
Yes, it does. I found it interesting with you talking about the buffer strips and also the benching and that's going on. I know a lot of that is happening over in the US at the moment. And like you, I can see that coming into UK agriculture as mainstream. So yeah, it's quite interesting listening to you talk.
Oh, good. Okay, thank you for your question. Thank you.
Harry Henderson has a question, if you want to unmute.
Yes, hi Jane, great
Hello.
presentation. Yeah, just a question really around the UK productivity scheme offered to farmers. It offers funding for farmers to purchase a no-till drill. I just wonder, a no-till drill tends to be a fairly specialist piece of kit for a specialist farmer. Is that a step too far? Should the productivity scheme also offer funding for a direct drill, one-pass, time-based drill that would get farmers on their way rather than push them to the furthest reaches of crop establishment?
It's a really, really good question, and this is a dilemma for agricultural policy. One size does not fit all. And I think one thing we learned from the SOAP project, where we were looking at these different conservation tillage practices and the whole range from conventional practice to zero till, where particular farms and farmers and soil types and crops fit on that continuum is really on a field by field basis, and a one size fits all is not going to work. Certainly we found that there are issues with direct drilling, particularly on clay soils, heavy, wet, cold soils, you know, trying to drill into the residues, the stubbles, you know, there are issues there, much easier for farms on light soils to overcome some of those issues. So I think what you're saying is a one size fits all is not the right approach. We have to be much cleverer in applying appropriate tillage practices to appropriate conditions. I mean, we know this just in terms of moisture content of soil when you carry out these practices is critical. Similarly, the type of soil and the type of crop, etc., are going to be very, very important. And I did mention this, I think people are now talking about transition. It's not, I'm in conventional and I'm going to conservation agriculture, or I'm going to direct drill, or I'm going to zero till or min till. It's this concept of transitioning, and that will not happen overnight. That's going to be a long process. And indeed, the benefits of that are going to be a long process. You're not going to suddenly increase your organic matter overnight. It's going to take a long, long time. And the problem with many farmers is that their drivers are short-term economic factors because of the marginal nature of a lot of farming. Not all farming, but a lot of farming is marginal. It's very difficult to be green when you're in the red. And that is the challenge that we have of supporting farmers to make these transitions, supporting them if they start to see economic fall in returns. It's like a J curve, that yes, you may get that decline, but then you have to see it up the other side. So I don't know, Harry, if that addresses your question. I agree with your concern. I think that's what I'm saying.
Yeah, it does. Yeah, we're on the same page. I'd just like to get in front of whoever makes these rules up, but I can't find out ever where the information comes from for these rules. Yeah, so very interesting.
Yeah.
Okay.
No comment as to who makes these rules.
A question from Andrew Heather, if you want to unmute. We've probably only got time for one more, I guess, Sarah, have we?
Hello. I'm just interested looking a lot at the water environment and how we're seeing quite an increase in these very big, high intensity, high volume rainfall events. Is that going to increase the sense of urgency among farmers? I'm sure the answer is yes, but I'm just wondering about agricultural extension work and whether there's a way to increase the training for people who've sort of long since left agriculture college and are not quite sure where to find out the information. It sort of feels as if there might be a call for the old ADAS to come back, perhaps.
Oh, sorry, that's yes. Well, yeah. How many people have said, you know what we really need? We need an organisation. Oh, I don't know, call it Agricultural Development and Advisory Service, something like that. That would be a good idea, you know. Oh yes, well, yes, I can't agree with you more. You know, the uncertainty of the impact of these extreme events, you know, whether it's drying or wetting or hot or cold or whatever it might be. Yes, and actually there's a call for arms for the institution, actually, that this is exactly what the institution should be doing in terms of being a focus on where some of this advice might be held. What the mechanism for that is, I don't know, but certainly the membership of the institution has got many, many experts, many of whom are on this call, that will know this stuff and will be able to give their experience and advice. And I don't know whether that's how that's going to be delivered. I'm not sure off the top of my head, but I could also do a plug for Cranfield, because we run courses on these sorts of things, short courses on erosion and conservation, and we're more than happy to put on those sorts of courses to help people who feel that they need the skills in that area. But maybe Sarah and Charlie, it's something, and Paul, it's something that the institution should explicitly, I think it does implicitly, but it should explicitly offer our membership as well.
Maybe there's an opportunity to seek grant funding to enable it to be taken more widely.
Yes, and to be fair, organisations like the BBSRC did have a training programme. What was it called? AATP, Advanced Agricultural Training Partnerships. And that was exactly these sorts of courses. I think that's come to an end now, but the legacy of that is that we still run a number of courses at some of the universities in this sort of area. Now, it happens that the erosion one and conservation one was at Cranfield, but Nottingham, Reading, other universities were involved as well. So, and at that, when that scheme was running, it was actually free to professionals who wanted to join those courses. But I think that's come to an end now, sadly.
Okay, so there's more questions, but I'm afraid we've run out of time. So maybe if you wanted to ask those questions, I'm sure Jane would happily answer them. So really, I'd just like to say thank you, Jane, for taking some time out to present today. I found it really interesting. I'm a bit worried about you getting rid of ploughing, though, as a few people will know what I do for a hobby. And you've got to kill the blackgrass, don't forget.
Oh, I know. Oh, that's another seminar. Somebody else can give you
so I'm sure everybody else found it really interesting. So just before we close, I'd like to thank you all for joining us today, and hope you will join us for our next lecture on the 10th of November, where Tim Shaman will be talking to us about controlled traffic farming as a protection aid for soils, which I also think is really interesting as well. So please put that date in your diary. Also, another date for your diary is our annual conference, which we're doing virtually this year on the 4th of November. So please see the website, get booked in, and spread the word. So thanks again, everybody, for joining, and I'll see you all next time. Bye for now.
Thank you.